Hello chemistry students, I'm going to take you through some balancing equations practice. I would recommend that you try these on your own and then watch me work them out. So one of the things that will be helpful for you as you're working through this is if you can identify where polyatomic ions are located in the problem. That will be good for you. So notice that NO3 is here and here. That's nitrate. So this is nitric acid, and that's barium nitrate over there. But the fact that the NO3 stays together will actually make this equation a lot easier to balance. So right here in the middle, we're going to separate this off and balance the things that are present on both sides. So on both sides there is hydrogen, there is oxygen, separate from the nitrate. See, it's in the OH there and in the H2O there. And then there's barium, and then nitrate. Okay, and what I'm going to do is I'm going to count and keep record on both sides. And I probably won't do this for all of them, but we will do this for some of them at least. So I'll go through, and right now we currently have 3 hydrogens on the left side, and then on the right side we have 2 only. Okay, if we keep track of our oxygens, excluding the ones in nitrate because we're going to count them separately, we have 2 here on the left side, and 1 plus, those are in the nitrate, so there's only 1 there. Okay, so those are in nitrate, we're not counting them right now. 1 barium on the left and 1 barium on the right, and then 1 nitrate on the left and 2 nitrates on the right. Okay, so when all these numbers are the same, this will be balanced. Right now, it's not balanced. So we're going to change some coefficients to see if we can make things better. Now, you can randomly pick somewhere to start working. Usually you want to do the oxygen and the hydrogen last, especially if they appear in more than one place. So I'm going to start with the nitrate, and that'll be an easy enough fix because I can put a 2 here, and that will change this from being 1 nitrate to 2 nitrates on the left side. It also, remember, there's more than just nitrate in that formula, there's also hydrogen there. So now I have 2 H's coming from here plus the 2 H's here, so I have a total now of 4 hydrogens. Now that might give me some information that'll help with something else, because I might notice that I've got 4 hydrogens and 2 oxygens, and on the other side I have 2 and 1, and both of those come from the water. So what I'm going to do is I'm going to put a 2 here, and that will make it so that I have 4 hydrogens and 2 oxygens. And if you look down and check, all the numbers now match. And that means that we have balanced this equation. Now, you can either leave these blanks, you could leave it blank, or you could put a 1 there. I'm going to leave it blank because if we've written the formula, we know that it appears once. If we put a coefficient more than 1, then we know that we have more than 1 of that. So we've balanced that equation. All right, I'm going to erase that so I can move on to the next one and have some space to write. Get my pen back. All right, so the next one, we have carbon, hydrogen, and oxygen present. This one could be really challenging, especially for beginning equation balancers. And we're definitely going to do oxygen last because oxygen appears in several different places throughout this equation. I think I will start with balancing the hydrogen, but I guess first we could, the carbon. But first we could go through and count how many of each atom are on both sides. Make sure you add the hydrogen from all places where it's present together there, so that one's 4, and then there's 3 oxygens total, counting here and here. That's a difficult skill for beginning balancers to learn, is to count the element everywhere it's present on the left or the right side of the arrow. All right, and that one's 2. All right, so let's see, carbon, I'll start there. So simple enough, I can put a 2 there. That will change the carbon to be a 2. It will also change the oxygen to be 5 now. So that fixed one problem but created another. That's fine. Let's look at the hydrogen next. I think that'll be the easiest fix. So 4 on the left, 2 on the right. So I'm going to put 2 there to double that. Now that's going to be 4, but that also changed the number of oxygen. 2 times 1 plus 2 times 2 gives us 6 total oxygens. Alright, now that does create something that's easier for us to fix though, hopefully, because we need 3 more oxygens on the left side. Actually, this is not looking like it's going to be particularly easy to fix. So to get 3 more oxygens, that's not going to happen here with a whole number because that's an even number. So when you run into a situation like this where you have an odd number of something and the only way you can really balance and make it work is with an even number, sometimes you have to double something. So that's what I'm going to do here. So I'm going to double the C2H3OH, and that's going to cause me to have to make some changes here, so that those are both going to change now. Let's go back and recount everything. So carbon is now going to go up to 4. Hydrogen is now going to go up to 8, and then oxygen is now going to be 4. Okay, and on the other side, let's go back and balance the carbon again. Now we're going to have to do 4 here, and then we're also going to have to do 4 over here for the water. Okay. And that's going to make it so that total we have, let's see if the hydrogens work now. We have 8 hydrogens. Yes, that does work. And the oxygens, let's count those up. 4 times 2 is 8, plus 4 is 12. All right, now that does make something that we can fix. So we need to add 8 more oxygens to the left side to make this have a total of 12. So the way that I'm going to add 8 more is I'm going to put a 5 here because we already had 1. That's another thing that can be confusing. And now when I check, I have 2 oxygens here plus 10 here. 5 times 2 is 10, so that makes 12. Okay, and that equals the 12 oxygens that I have total on the other side. So as you can see, that was quite a bit of work, but we did get there eventually, balancing everything out. All right, hopefully we'll come into some slightly easier ones as we work through this, and you'll get faster at these as you go. All right, so we've got on this one Si, F, H, and O. All right, so on the left side we have 1 silicon, 4 fluorines, 2 hydrogens, 1 They're not all hard, y'all. Just the first 2 on that worksheet are challenging, shall we say. Okay, hydrogens in 2 places, so make sure you add them together. You get a total of 4 there. Silicons in 2 places, you got 2 of those. Fluorine, there's 6, and oxygens, there are currently 3. Now, whenever I see a 2 to 3 ratio, that's the place where I usually start, because in order to find the least common multiple of those, that's what you're going to have to do to balance this equation. So I'm going to have 12 would be the least common multiple of those, so I'm going to make the changes necessary so that there would be 12 fluorines on both sides. So that would mean I would have to do a 3 here. Oh, excuse me, that would be 12 now. Okay, and then I'm going to have to multiply this one by 2 to make that one 12. Now that made some other changes here as well. So there's also silicon present there, so now my silicon has changed to 3. There's silicon in that one. Oh look, that's good. That one changed to 3 as well. There was also hydrogen present here, so 4 hydrogens here plus 2 here, that makes the hydrogen 6. Okay, so let's do the hydrogen next, since we can clearly see that, and it's an easy enough step. Multiply 3 times the H2 to give you 6 hydrogens, so now this one is 6 on both sides. And the last thing here is the oxygen. Well, let's look at what that change we just made. Now 3 times H2O, well that means there's 3 oxygens on the left side, and that makes it look like everything's balanced. So that one is done. All right. All right. So let's do another one. We've got magnesium, boron, hydrogen, and oxygen. All right, count them up. So there's 3, 2, 2, and 1 on the left side. I'm always putting this under the reaction arrow. That's the important place because we got to have before and after equal. Okay, 1, 2, oh, no, it's not 2 because there's hydrogen here and here. So 2 plus 6 would give me 8. 2 borons and 2 oxygens. All right, I'm going to usually start with metals. It's a good idea if you follow the order from the notes. So I'm going to start with the magnesium, make the change necessary to make there be 3 magnesiums on this side. So, all right, that also changes oxygen and hydrogen. So now it'll be 6 oxygens and let's see, 6 hydrogens here, 6 hydrogens there, so that'll be a total of 12 hydrogens now. All right, so boron is still balanced. It may not be after I change whatever I do next, but let's see if I can make the hydrogen work. Oh, that's good. See the 2-to-1 ratio here and the 2-to-1 ratio there? That means you're getting close. Okay, so to go from 2 hydrogens to 12, I would need to multiply the H2O by 6. That will make it so there are 12 hydrogens, and also so that there are 6 oxygens. So that is actually all we need to do to balance this one. That completes it. All right. All right. This one is just symbolic, so we can give that one a try really quickly, hopefully. Okay, so there are stars, cash symbols, and percent signs, and we can just count on both sides. There's 2 stars, 3 cash signs, and 1% on that side. There's 1, 1, and 2. And then, I guess I don't know, balance the stars first maybe, so I put a 2 there. And that makes it be 2 stars and 2% signs. And then, oh snap, I should have done the 3-to-2 ratio first. Let's do that. Follow my own advice here. All right, so the least common multiple of those is 6. I'm going to make the changes necessary to make these 6. So let's take a stab at that. That's going to be a 2. And then that's going to be a 3. All right, that also changes the number of stars, makes it 4. And then to fix the stars on the other side, I'm going to have to put a 4 there as a multiple. That makes it so that there are also now 4% signs. And then you'll have to multiply that by 4 to make it balance. So that is it for that particular example. All right, so hope that those examples are helpful. You'll have some more practice for balancing equations. And thanks for watching.